So Ralph?
Yes, I'll take the recording.
Okay, Mari? No
Yes.
Mari. Oh, okay, thank you. Okay, you two are going to be responsible for making sure that I record. And we are recording now, I think. Are we recording?
Yes, ma'am.
Okay, groovy. So first of all, let's take this point and see, how do we know that it really is on the unit circle? So what's true about every point? What is true about every point on the unit circle? What do we know about X and Y if XY is on the unit circle?
That all ends in one. This is
Yes, it should equal 1, but what's going to equal 1?
The distance from the origin.
All right, and the distance from the origin is?
The radius.
Yes, and that's the 1. So what's the other part of the formula? We usually think of it as the Pythagorean theorem.
x squared plus y squared.
Yes. Every single point that really is on the unit circle has to satisfy this equation. So let's see if P2 really is on the unit circle. And then we'll answer part 1, and then we'll look at where it is and how we know. That's the part that you were wondering about, Sorrel?
We're just wondering about part 3 of this.
How we know where it is?
It's in part 3. It says if we let theta to be the angle corresponding to
Oh,
P2,
part 3. Okay. Yes. Then we'll do that definitely all the way. Okay. So we've got X is negative root 5/3. Y is negative 2/3. And we wonder, does it really equal 1? So how do you square negative root 5/3?
You square the numerator and denominator.
And what about the negative?
You'll change that to a positive.
Good. We squared that also, and negative squared is positive, so we have positive. And square root of 5 squared?
5.
Good. 3 squared?
9.
Beautiful. Negative squared?
Positive.
2 squared?
4.
3 squared?
Also 9.
How do we add fractions?
You
The
can
denominator
keep the
is the same.
denominator to the same and
Yes.
add the
Just add
numerators.
across.
And 5 plus 4 is?
9.
And 9 divided by 9 is?
1.
So this is how you verify that a point really is on the unit circle. Yes, Lynette. I can't hear you yet. Did you have a question, Lynette?
No, I'm sorry. I was talking to my daughter.
Oh, that's okay. That's okay. No worries. I just wanted to make sure I wasn't missing somebody's question. Okay, so now I know Sir Ralph knows how to do this part, but this is part of what we're going to look at today, so it's fun. If we know a point on the unit circle, how can we figure out what the 6 trig functions are? And the thing we're using is this triangle. So if theta is a central angle, and central angle only means it's an angle that starts at the origin and goes out. So it's a central angle. And if we know that, what can I mark on this triangle so that I know it's a triangle on the unit circle? What identifies a triangle as being a right triangle, as being in the unit circle?
One union, it has all equal one angle, all angles.
Good. So we've got this triangle, and we know, actually, let's let this be AB so we don't get confused with lots of X's and Y's. So let's let the vertical length be B and the horizontal length be A. What is the cosine of theta?
A over 1.
So it's just going to be, for the unit circle, it'll just be A. But yes, A over 1. And the sine of theta?
B.
B.
Good. Tangent of theta? In terms of A and B.
B over A.
Beautiful. Which function goes with cosine?
Secant.
Good. And how does secant go with cosine?
1 over A.
Good. Yeah, they're reciprocals. And what function goes with sine?
Cosecant.
And how are they related?
Reciprocal.
Good. And which function goes with tangent?
Cotangent.
Beautiful. So cotangent is going to be, if it's the reciprocal of tangent, it's going to be
A over B.
good. So it's true that cotangent is 1 over B over A, but you don't have to take a reciprocal of a fraction this way. You just flip it to take the reciprocal of a fraction. So you'd get the same thing. Okay, so we're going to use these relationships to find the 6 trig functions of this point. So let's write our point down. Our point is -√5 over 3 -2/3. And somebody tell me, did I put P or P2, did I put it in the correct quadrant?
Could you say that question one more time?
Yes. Did I put P in the correct quadrant?
No, because they're both negatives.
That's right. Where does it belong?
Quadrant 3.
Beautiful. So let's draw it there, because that'll help us in answering the question you have. So we still have A and B. We still have 1, but now we know that B is negative 2/3, and A is negative root 5 over 3. And what does that make the cosine of theta?
Negative square root of 5 over 3.
Good. Beautiful. And what about the secant? We're going to always think of these as together.
3 over negative 3 over square root of 5.
Good. And the sine of theta?
Negative 2 over 3.
The cosecant of theta?
Negative 3 over 2.
The tangent of theta?
Negative 2 over 3 over negative 5 square root of 5 over 3.
Okay, beautiful. And what is one way to simplify or make this complex fraction into a regular fraction?
Least common denominator.
Okay, good. And we're going to multiply numerator and denominator by the inside least common denominator. Well, they're both 3's. So what is the least common denominator between 3 and 3?
3.
Good. And are we going to multiply or are we going to divide?
Multiply.
And this is what I'm talking about. We've got negative 2 over 3 times 3, and we've got negative square root of 5 over 3 times 3. Are we going to multiply this 3 by the negative 2 over 3, or are we going to divide?
Multiply.
We can multiply. If we multiply, we get negative 6 over 3. And does that reduce?
Yes.
And what do we get?
Negative 2.
Good. So the easiest way to deal with complex fractions is to divide. And you're just left with the numerator of one of the fractions. And so in the numerator here, we'll have negative 2, and in the denominator, we'll have
Negative square root 5.
beautiful. And what can we do with those negatives?
Cancel them out.
Yeah. So we have 2 over root 5 for the tangent. And what does that make the cotangent?
Square root of 5 over 2.
Beautiful. Beautiful. So if you don't rationalize in between, then it's really easy to go from one answer to the next. And then if you have to rationalize, I would encourage you to rationalize at the end. So if we had rationalized the tangent here, let's just do that. So we have 2 over the square root of 5. And how do we rationalize that?
Multiply both the numerator and denominator by square root of 5.
Beautiful. And in the numerator, we'll get
2 square root of 5.
and in the denominator,
5.
okay. So here's the tangent of theta. If I want to, there's a theta there. If I want to write down the cotangent, what am I going to flip? What fraction am I going to take the reciprocal of?
The
Square root
first one.
5.
Yeah.
Square root 5 over 3.
Well, so if, say you don't get that, you say you take this answer and you flip it. Because I've seen a lot of students do this. And now I'm going to rationalize again. And we're going to multiply by. What do we multiply by?
2 root 5.
Just root 5. We don't need to multiply by the 2. We can, but it will just make all of the numbers bigger. So the key thing is we want to get rid of this root 5, the square root of 5. And to do that, we've got to multiply by another square root of 5. And that's why we only have to deal with the square root of 5s. What do we get in the numerator now?
5 root 5.
Beautiful. And in the denominator,
10.
and can we reduce? We've got 5 root 5 over 10. Can we reduce
pull
that?
out of 5.
Good. 5 goes into 5,
Once.
and 5 goes into 10.
Twice.
Beautiful. And we end up with square root of 5 over 2. And I just wanted to do that so that some student maybe will understand why it's really helpful to you to wait till the very end to rationalize. Because we ended up having to rationalize cotangent again, and then we were able to reduce it, and we got the same thing we would have gotten if we had just taken the 2 over square root of 5 value of tangent and flipped it. Okay, so we've got the 6 values. We decided that P2 is in the third quadrant. Why is it in the third quadrant?
Because both x and y are negative.
Good. So third quadrant is negative, negative. That means that, let's see, sine and cosecant go with this second negative, so they're both negative. Cosine and secant go with the first one, so they're both negative. Why are tangent and cotangent positive?
Because a negative divided by a negative is a positive.
Perfect. Okay, now, so Ralph's original question was this. So if theta is the angle that is described starting at the positive x-axis and going to this terminal side of the triangle. Then the 6 trig functions are going to be the same. So if this angle is theta, the theta here, then we've got the 6 functions. So Ralph, is that a confusing question?
So you said if we had theta, right? You said we
Mhm.
had all 6 functions?
So if theta is this angle that starts at the positive x-axis and goes to the terminal side of the triangle, then the 6 trig functions of theta are the 6 values we just found.
I see, okay.
How can I ask that more clearly?
No, I understand how it works from that side, from one side to the other.
Okay. Okay, groovy. Let's look at some, or actually, let's finish what we were doing last time. And then look at this. Actually, I wanted to do this first. Okay, so let's take a blank unit circle and let's fill it in. Where would you like to start? Because I want you to practice doing this. Make lots of copies of this blank one that I sent y'all and just practice every day filling it in. Where would it be good to start?
The top.
Okay. What is the top?
I don't know.
What is this distance? The distance from the center to this point at the top of the y-axis.
Are you saying what's the point of pi over 2?
Yes.
That would be 0, 1.
Awesome. Where else can we fill in?
Pi over 3 would be 1/2 on the x value, and square root 3 over 2.
Excellent. And how do you remember that pi over 3 starts with 1/2 instead of starting with square root of 3 over 2?
I just remember it as square root 3 over 2 is bigger than 1/2.
Okay, good. That's how I remember it too. Now what?
Then the pi over 4, that's square root 2, all x and y. Square root 2 over 2.
And we're going to remember that that's the same as square root of 2 over 2 is the same as,
Wasn't it 1 over square root of 2?
it is perfect. Thank you. How are you, Mari?
Oh, good. And you, teacher?
I'm fine, thank you. I'm here, so that's wonderful.
Nice.
All right, what shall we do next?
Pi over 6 is the opposite of pi over 3, so it will be square root 3 over 2 for x and 1/2 for y. 1/2 for y.
Beautiful. Does square root of 3 over 2 always go with 1/2?
Yes.
That's right. That's exactly right. Thanks, Lynette. So if you know one of the coordinates is square root of 3 over 2, you know the other one is 1/2, and if you know one of them is 1/2, then the other one has to be square root of 3/2. And then you have to adjust for what? Like, what if I say the point we're caring about is in quadrant 2?
Oh, it's this
Oh,
quadrant 2. You just have to adjust the positive and negatives. So
That's right.
quadrant 2 is negative x and positive y.
Okay, good. And what does that make? First of all, what is this angle? And what is its what are its coordinates?
That angle is, well, are you talking degrees or the
Either degrees or radians.
so if the whole thing is 180, just remove 30, so 150 degrees?
Beautiful. And 150 is the same as 5 pi over 6. Every single angle that has these coordinates is going to have a denominator of 6 in radians. Okay, and what are the coordinates of this point?
Negative square root 3/2, positive 1/2.
Great. How did you know?
It's quadrant 2, negative x, positive y. And they're all asymmetrical.
Okay, exactly right. We forgot one point in quadrant 1. What is the point here that's shown just with nothing describing it?
1,2. I mean 1,0.
Beautiful. And we call this 0 degrees or 0 radians, but it's also going to be the same as what?
2 pi.
Yes. So 2 pi radians, or how many degrees?
You could also say 360.
Good. So 0, if you're starting here and going nowhere. 360, if you start at 1, 0 and go all the way around the circle, you end up back here to 1, 0. Let's fill in the rest of the points on the axes. What is the other point on the x-axis?
Negative 1,0.
Good. And what are its angles?
Uh, 180.
Good. And
I'm not sure what the pi thing is.
just pi.
Pi. Okay, cool.
And we always measure these things starting at the positive x-axis and going counterclockwise. If the angle has positive value. Okay. So let's see. We've got one more point on an axis. What is the other point on the y-axis?
0, negative 1.
And what do we add to 180 to get to this angle?
90.
Yeah, so let's see. 180 plus 90, 8 and 9 are 17 maybe? And then 1 and 1 are 2. So we get 270 degrees. to see how many radians this is, we're going to take pi and add pi over 2. So we have pi plus pi over 2. And what do we need to do to add those?
Have a common
Find the common
denominator.
denominator.
Yes. Somebody asked a question. Do we have an exam today? An exam is due today, is that right?
Yes.
The exam over the prep?
Yeah.
Yes,
that's
ma'am.
Yep.
today.
Yes, you take that on your own. So
The only thing
to
is,
take,
there's a password on it.
yes, but if you go to our notes page, you see that it's, the test page, you see that the password is exam 1. Capital E, then XAM, no space 1. Because I'm not very creative. And I want to remember them. So you take the exam in Alex, but I don't care whether you get the answers correct or incorrect in Alex. I want you to write down your work as neatly as possible, number your questions, and upload them to our exam page. I'll go ahead and send out that exam page again. Would that help?
Yeah, that'd be helpful.
Okay, groovy. La, 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 the dots, la, 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 connect the dots. Thank you for asking the question.
We only have one try for this exam.
2 tries. And if you want
Okay.
another try, I will give you another try. I would really prefer that you do well. So, because doing well means that you understand the material.
Yeah, cool.
Okay, let me pull up this. Page. Go la la la. And it's due today?
Yes.
Yes, ma'am.
Okay, great. I put the password and the link to the Canvas exam page in that email. So
Is
the
there a
exam
time?
exists. You say again?
Is there a time limit to this exam?
No, I don't believe in time limits. It just, all it does is create anxiety for some students. The students who it doesn't create anxiety for aren't limited by it. So it just doesn't help anybody, and I don't see how it helps me. So I don't do it. And if you want to, you can go through Alex write down the questions, turn Alex off, work every question on paper, and then upload your work in Canvas. I do not care what you do in Alex. That is not part of your grade. Okay. Okay, because it's the work that you do that I care about. All right. Let's look at the rest of the angles that are important to us in quadrant 2. So this angle at the top in quadrant 2, how can we find it if we know that pi over 2 is 90 degrees?
Add 30.
Good. And let's see, 90 plus 30, 9 and 3 are?
12.
Good. So this is 120 degrees. And I'll give you a break right now. Pi over 6 plus pi over 2 is 2 pi over 3 when you reduce it. How can we find out the measure of this next point?
Add 30 again.
If we add 30 again, we're going to end up at 150.
Add 15.
We can add 15 or we can add 45 to 90. 15 is fine. So we get 135. Adding 15 or pi over 12 to 2 pi over 3 is a lot of work. So I'm just going to count by pi over 4s. We've got 1 pi over 4, 2 pi over 4s, 3 pi over 4s. Did y'all see that?
Yes.
That's really, we'll work on that skill because it's very important. In fact, let's use that skill to label the rest of the angles that are the same as pi over 4. So if this is 3 pi over 4, what is the next point? How many pi over 4s?
4 pi over 4 is
4 pi over 4. And then we get to
5 pi over 4.
5 pi over 4. And why isn't 4 pi over 4 a 45 degree? You know, why doesn't it have these coordinates? Oh yes, everybody, some students came in late. Please do sign in with your name and your banner ID and send that to me direct message. Okay, why is 4 pi over 4 not in the family of pi over 4 and 3 pi over 4?
So you can reduce the 4.
That's right. If you can reduce, you have to reduce. And so you'll hear me say often, in reduced form, so if the angle in reduced form has a denominator of 4, it's going to be in the family of pi over 4. All right. So if this is 5 pi over 4, how many pi over 4s do we have at 270?
6.
Okay, I'm going to write that down. And then how many pi over 4s do we have at the next spot?
7 pi over 4.
Good. And let's reduce 6 pi over 4 because we never did attach a radian measure to 270. how can we reduce 6 pi over 4?
You can take out a 2.
Good. 6 divided by 2 is
3,
4 divided by 2 is
2.
good. So we end up with 3 pi over 2. Let's do that same thing to get all of the angles that are pi over 3s. So we have 1 pi over 3. And then if we go 60 degrees again, we end up with 2 pi over 3. Where do we end up if we go 60 degrees again? From 120 degrees, if we go 60 more degrees, where do we end up?
180 or 3
180.
over 3 pi over 3.
So 3 pi over 3, that's 180. So where is 4 pi over 3? Andrew,
Where's what?
where is 4 pi over 3? If 3 pi over 3 is at 180 or pi, where is 4 pi over 3?
Not sure. It doesn't look like it's on the thing.
Well, if 3 pi over 3 is here and we add 60 degrees, that's here. So we'll end up with 4 pi over 3 at this point down here. And where do we end up if we add 60 degrees again?
At 300 degrees.
Yes, that's right. So we have 300 degrees or 5 pi over 3. And where is 6 pi over 3?
It's at 360 or 0.
That's right, because 3 pi over 3, 6 pi over 3 reduces to 2 pi. Groovy. So we're filling this in. Let's do one more thing. Let's do the counting by pi over 6s. So 1 pi over 6. Where is 2 pi over 6? Where do we go if we add 30 degrees to pi over 6?
To pi over 3 because it
That's right.
reduces.
That's right. And if we add 30 more degrees?
120.
We actually end up right here.
Yeah, sorry.
So 1 pi over 6, 2 pi over 6s, 3 pi over 6. And where is 4 pi over 6?
At 120.
Good. And where is 5 pi over 6?
50.
Yes. And 6 pi over 6?
180.
7 pi over 6.
210.
If we add pi over 6 again, so where is 8 pi over 6?
240.
Let's see, 9 pi over 6.
270.
Good. 10 pi over 6.
300.
And 11 pi over 6.
330.
Good. And I want you to notice something. The pi over 6s are all 30 degrees away from the x-axis, all of them. So you don't have to remember lots of things. The 60-degree angles, the pi over 3 angles, are all, you can think of them as 60 degrees from the x-axis or 30 from the y. They're all that. They all are the same. And the same with the 45s. All of the pi over 4 angles. So 1 pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 are 45 degrees from any axis. We never filled in the signs for quadrant 3. So here it is. What sign does X have in quadrant 3?
A minus or a negative,
Good. And Y?
also negative.
Good. I know that people get picked on for using the word minus in classes, but I've heard so many famous mathematicians use minus, so I don't think it's a big deal. Okie doke. And what about quadrant 4? What
Minus
sign?
positive.
Good. So if we know the signs around the unit circle, do we know also every value of all of these points?
Yeah,
And tell me why, how?
because if we know one, we can just translate it through the signs to get the others.
That's right. Here's a pi over 6. Here's another pi over 6. I'm going to take these coordinates and put them on this other spot and just adjust for the quadrant, adjust for the signs in the quadrant. So that means I'm going to make X positive and negative, Y is going to stay positive. What about 7 pi over 6? What are its coordinates?
That'd be negative square root of 2 over 2. And then negative 1 over 2.
Good. Good. So we have exactly the same coordinates if we think of them as adjusted for the quadrant. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Quadrant 1 is plus plus. Quadrant 3 is minus minus, but the numbers are the same. And what about 11 pi over 6? What are its coordinates?
Positive square root of 3 over 2. And negative 1 over 2.
Good. Good. And that's because quadrant 4 is positive, negative, positive, negative. I'm going to make another assignment, just another little assignment for everyone to fill out a blank unit circle and upload it, because I want y'all to do this every day. Just fill out a blank unit circle. Pretty soon, these values are going to be part of your, you'll have Alzheimer's, but you don't know your children, but you know these angles. All right. So a thing that I did, because I don't know why, is I wrote out the first quadrant values for the primary angles: 0, pi over 6, pi over 4, pi over 3, pi over 2. So here's the sine, here's the cosine, the cosecant, the secant, the tangent, the cotangent. And part of the reason why I did this is that tangent and cotangent get a little bit weird for the pi over 6 and pi over 3s. You can see that some of the values are undefined. Why would something be undefined? Why would cosecant ever be undefined?
It tries to divide by 0.
That's right. Cosecant is cosine over sine. So if the sine is 0, it'll be undefined. And which other trig function has sine in its denominator? Cotangent, because cotangent is cosine over sine. So it also is undefined at 0. The secant and the tangent are undefined at pi over 2, because at pi over 2, the cosine is 0, and both of these have cosine in their denominators. And then I went through and wrote out the related angles. So for pi over 6, in quadrant 2, you have 5 pi over 6. In quadrant 3, you have 7 pi over 6. In quadrant 4, you have 11 pi over 6. For pi over 4, in quadrant 2, 3 pi. Anyway, it just continues. So I thought maybe that would be helpful to you. And I wrote out the signs, SIGNs, of each of the trig functions in the various quadrants. So this is all on one document, and the name of this document is Helpful Things or something, Helpful Facts. And the main reason why you have sheets like this is so that you don't need them eventually. But I don't want you to worry about memorizing something like this. I just want you to practice filling in the unit circle. And then this will be unneeded. You won't need it. Also, I redid this first page of this lesson because I noticed that the image of the unit circle that I used here was very, very dim and didn't really show up, and you couldn't see that these are thetas. So I redid that, because why not? And now, let's look at finding the 6 trig functions for a point. And we also are thinking for theta, if we know where the point is, we know what theta is. Theta is always measured from the positive x-axis to the terminal side, or the angle, the hypotenuse of the triangle. So theta here and the point PXY here are related. That's what I meant about the third part of the question 2 that we went over earlier. Okay, so this is actually the same. How funny. Well, not quite the same. First of all, where is this P? Where is negative square root of 5 over 3 comma 2/3?
Quadrant 2,
Good. And how do you know?
because it's negative positive.
Good. So we have our point negative square root of 5 over 3 positive 2/3. And we've already done it once today, but let's go ahead and write down the 6 trig functions for that point or its related angle. So what is the sine of theta? Sine goes with which coordinate?
X,
Almost.
Y,
Sine is second in, so cosine comes first alphabetically and x comes before y alphabetically. Okay, so yes, sine goes with y, and that means that the sine of theta, where theta is marked in blue here, is going to be
2 over 3.
good. And who is sine's friend?
Cosecant.
Good. So the cosecant of theta is going to be
3/2.
beautiful. The cosine of theta is
-5 square root of 5 over 3.
good. And who is cosine's friend?
Secant.
Cosecant.
Almost secant. So a co always goes with a non-co. Cosecant goes with sine. Cosine goes with secant. Cotangent goes with tangent. So it's always mixed up. All right, so what do we know that the secant is?
-3 over square root of 5.
Awesome. The tangent of theta?
Is it like 2/3 over 1?
2/3 over negative square root of 5 over 3, maybe?
Oh, it's
'Cause-
this one.
Because tangent is opposite over adjacent, or b over a, or y over x. Okay, and what can we do to reduce or simplify this fraction?
Find a common denominator, but it looks like it already has one.
And so what do we do with it?
Vertically add.
Divide them.
Yeah. So we're going to, are we going to multiply or divide?
Divide is faster.
Yes. Okay, so 2/3 times 3 is, what divides out?
3.
Good. And we end up with 2. And negative square root of 5 over 3 times 3, what divides out?
3.
And we're left with negative square root of 5. So what is tangent's friend?
Cotangent.
And so the cotangent of theta is going to be
Negative square root of 5/2.
beautiful. Which ones do we have to rationalize?
Secant and cotangent.
Secant and tangent. Yes.
Tangent, sorry.
And both of them, what are we going to multiply both of them by to rationalize them?
Square root of 5.
Yes. So we've got square root of 5 over square root of 5 here. And square root of 5 over square root of 5 here. In the top one, we have a negative times a positive. So
We
we're
wouldn't
going to have,
multiply by negative square root of 5.
no, because the negative is going to stay. If we multiplied by negative square root of 5, we would have negative 3 square root of 5 over negative. We would still have a negative square root of 5. So negative 5. So the negatives would still divide out. It wouldn't be wrong. It would just be extra. So we're only having to multiply by the square root part. In the numerator, we're going to have
3 square root of 5.
and in the denominator.
5.
And for the tangent, in the
2
numerator,
square root of 5.
and in the denominator.
5.
Good. And a thing you probably remember, but some students don't. If you have a fraction that is negative, that is exactly the same as the numerator being negative, which is exactly the same as the denominator being negative. So no matter where the negative is in a fraction, you can pull it out. And out front is the best place for it to be. But sometimes we also move it to the numerator. Okay. Groovy. That was very long. I want y'all to take the point negative square root of 7 over 3, comma, square root of 2 over 3, and find the 6 trig functions. And I'm going to be here, but disappear. And pause the recording. Who's going to remind me to restart the recording? Okay, great. And was there any aspect to this question that you think would be good to go over before we continue?
Actually, I do have a quick question.
Yeah.
When I was doing that, I rationalized, sorry, I flipped tangent before I rationalized it. And I also flipped it after I rationalized it. I got the same answer. Will that always happen?
Always, always, always. It doesn't matter which way you do it. I think it's simpler to rationalize at the end, flip it before you rationalize, but it's correct either way.
All right, cool.
Okay. So let's find the 6 trig functions for 7 pi over 3. And where is that? Oh my gosh. If I recall, we went up to 5 pi over 3 in the unit circle. Where is 7 pi over 3? Where did we land? Where did we say we landed if we had 6 pi over 3?
at 360 degrees.
Yes,
We're at
good.
0.
So where will we be if we add another 60 degrees?
At 60 degrees.
Yes. So 7 pi over 3 and pi over 3 have exactly the same trig function. And that's because we call them related. So if we have theta and it equals this other theta plus or minus 2 pi, these have the same trig functions. Do you think it only works if you add or subtract 2 pi?
No.
That's right. So we could go, let's see. We've got 7 pi over 3, 7, 8, 9, 10, 11, 12, 13. Wait, no. Now I'm confusing myself. 4 pi is the same as 12 pi over 3. So 12, 13. So 13 pi over 3 is the same as pi over 3 is the same as 7 pi over 3. And it's easier to see that if you take 2 pi and you write it with a denominator of 3. So how can you do that? If we have 2 pi over 1, how can we write that as a fraction with a denominator of 3?
Multiply the numerator and denominator by 3.
Very good. So 3 times 1 is 3. What about the numerator?
It'd be 6 pi.
Cool. So, and I noticed that pi over 3 plus 6 pi over 3 is 7 pi over 3, plus another 6 pi, let's see, 7 pi plus 6 pi is 13 pi. That was the next one that we talked about. So you can add and subtract pi over 3s by looking at 6 pi over 3. What fraction would we add or subtract if the denominator of the original function was 6? So what if we had 25 pi over 6? What would we add or subtract to figure out where on the unit circle that angle is?
Both pi over 6.
Yes, exactly right. So we take pi over 6 and we multiply. We want back. We have 2 pi and we want the denominator to be 6. So we multiply by 6 over 6 and we get 12 pi over 6. So how can I figure out where 25 pi over 6 is? And is 25 pi over 6 definitely a pi over 6 angle?
Yes. Because
How do we know it's a pi over 6 angle? Yes.
Because
It won't
25
reduce.
That's right. It will not reduce, so it has to go with pi over 6. all we have to figure out is what quadrant it's in. So how can we do that?
We can just, because 25 pi over 6 is the same thing as 12 pi over 6, like times 2. So it's 24, right? And then plus 1. So it would just be at 0 and then plus another 1 pi over 6, I guess.
Yes, so we can subtract off 12 pi over 6's. We'll subtract twice. So we've got 25 pi over 6 minus one of them. That ends up with 13 pi over 6. And if we subtract again, we get pi over 6. So we know we end up in quadrant 1. And the thing is, exactly as Ben said, we add or subtract multiples of 12 pi over 6. What do we add or subtract to locate the a pi over 4 angle? So what if we had 45 pi over 4? Which quadrant does that land in?
Well, we would do it by 8 pi over 4.
That's right.
So
And why?
because we're starting with 2 pi, and then it's 2 pi over 1, multiply both by 4, which is
Good.
8 pi over 4. And then you can just divide 25, sorry, by 8. Or
Yes,
the other way
good.
around.
So let's see. 8 goes into
then-
45. The biggest is, gosh, I'm forgetting my 8. The biggest is 30. Wait, no. My gosh. 8 times 6 is 48. 8 times 5 is 40. So 5? 8 times 5?
Yep.
And we're left with 5. What do we do with that?
That's how many eighths we go up, right?
Well, this is
So-
how many pi over 4s?
Yeah,
So
pi
we've
over
got
4s, yeah, not eighths.
5 pi over 4. And where is 5 pi over 4? Which quadrant?
Well, just
Is 5 pi over 4 bigger than pi or smaller than pi?
bigger than pi.
Is it bigger than, well, it's close to pi, right? So it's in the bigger side, so it's going to be which quadrant?
The third quadrant?
Good. So 5 pi over 4 is in quadrant 3. And that means that 45 pi over 4 is also in quadrant 3. And this symbol is an epsilon. It's the Greek E, and we're going to use it a lot. And I think we're close to time. Are we? Or do we have 10 minutes?
About 10 minutes, yeah.
It's 11:27.
Okay, awesome. Let's party. Do lots more questions. Okay, so we said that 7 pi over 3 was a pi over 3 angle, and it's in quadrant What do we add or subtract if we have a pi over 3 angle?
The question, sorry.
What do we add or subtract if we have a pi over 3 angle?
That'd be 6 pi over 3.
Good. So we've got 7 pi over 3 minus 6 pi over 3, and we land on
1 pi over 3.
so we're in quadrant.
1.
Good. And the coordinates for pi over 3 in quadrant 1 are does the 1/2 come first or second? I know that the
First.
that's right. Very good. And how do you remember?
Because I wrote it down on the unit circle.
Good. That's good. So, and if you just use your hand to think about 60 degrees, you can see that the distance across is much less than the distance up. Pi 3 square root of 3 over 2 is bigger than 1/2. So this y distance must be square root of 3 over 2. And pi over 3 and pi over 6 always have these two values. So let's write down some of these. The sine of 7 pi over 3 is
That'd be um square root of 3 over 2.
beautiful. And which one do we always do at the same time as sine?
Cosecant.
So the cosecant will be
2 over the square root of 3.
beautiful. Then we do cosine of 7 pi over 3.
It's just 1/2.
Good. And which one do we always do with cosine?
Secant.
So the secant of 7 pi over 3 will be
2.
Good. The tangent of 7 pi over 3
Square root of 3 over 2 over 1 over 2. And we have a common denominator of 2.
So we're going to multiply by,
Multiply by 2 or divide by 2. But yeah,
okay, great. And what do we end up with in the numerator? The big numerator.
the numerator we end up with square root of 3.
Groovy. And in the denominator.
1.
And so we can write this as
Square root of 3.
beautiful. And which one goes with tangent?
Cotangent.
The cotangent of 7 pi over 3
is 1 over square root of 3.
good. And which ones do we have to rationalize if we live in an Alex world?
We'll have to rationalize cosecant. We'll have to rationalize cotangent, and I think that's it.
That's it. That's right. Beautiful. And what do we multiply to rationalize the cosecant?
Square root of 3.
And what about cotangent?
Also square root of 3.
Beautiful. 1 times the square root of 3,
Square root of 3.
square root of 3 squared.
3.
2 times the square root of 3,
2 square root of 3.
square root of 3 squared is still 3. So you can see that the answer without rationalizing is much easier to put in your head as a pattern. 1 over
I have
square
a
root of
question.
3. Yeah.
Where'd you get the 6 pi over 3? The 7 pi over 3 minus.
Okay. That's a great question. So I can add or subtract 2 pi. But if I've got pi over 3 that I'm adding or subtracting with, I need 2 pi to have a denominator of 3. And to
I
get
see.
that, we're going to multiply by 3 over 3, and that gives us 6 pi over 3. So if you think in that way, with any angle that in reduced form has a denominator of 3, we're going to add or subtract 6 pi over 3, denominator of 4, 8 pi over 3, denominator of 6, 12 pi over 3. It just kind of helps to put things as simply as possible in your head to file.
Okay. Thank you.
You're welcome. Okay, do y'all all feel happy? Well, of course you do. You've been doing
Yeah.
pre-cal. Beautiful. Let's call it good because we don't really have time to do another whole question. Let's see. There's somebody asking something. Oh, and no problem, Natasha. I think she already left. Yeah, if you have to go ever, just go. And if you come in late, that's great too. Just pop in. If you can only stay for 10 minutes, that's great too. Just remember to sign in so that I know that you were there.
All right.
Okay. Yeah.
See you on Monday.
See you on Monday.